Hi, everyone. Welcome to another episode of Advent of Code in Kotlin. How's everybody doing today? Thank you, as usual, for deciding to spend your time with me or with us, because as usual, I'll, of course, be joined by a guest in just a little bit. If you are in the chat, please do. Yeah, just like some people here have already started to do. Give us a little wave, say hello, and as usual, I would be very much interested in hearing a little bit about how you felt about today's challenge, if you've done it. Because I'll be very honest with you, that one was a little spicy for me. There's a lot of small trickery in today's episode. I also want to make sure that if you're currently still on the fence of whether you want to watch today's episode or whether you just want to sit on the couch, first of all, these streams can be watched on the couch. Textbook is not required. But also, I have just seen a tiny little preview of what might happen on today's stream. And let me tell you, it's going to be well worth your time. That's all I'm going to say for now. Let's see what we have here. We have a couple of different points here. A lot of people saying that part 2 was a big challenge here. Yeah, lots of endorphins for the star in part 2. Second part was tough. There's a big question here, which I'm sure we'll get into later, which is I'm curious how long your solution of part 2 takes. Mine takes a few minutes to complete. Interesting. Part 2 for me takes 25 seconds. This one I find fun. 15 minutes, I assume to run, not to compile. Otherwise, that sounds like maybe a bug, or maybe you've decided to do it in meta programming, which I really hope you didn't. Other folks, of course, also here. Rob says it was not hard to solve. I didn't have time to refactor it to a solution that runs in milliseconds instead of minutes. Okay, but that's fair, you know. You get to the star, and then it's fine to move on. Yeah, but we're seeing a lot of differences here, especially the whole discussion seems to revolve around part 2. I'll show you a little preview here for what's about to come later. But today was one of those days where I couldn't get around doing a couple of a couple of drawings. We'll see those in bigger in just a little bit. Now, before we dive in, I want to very briefly, of course, give you some of the most important information about our stream. First of all, as you already know by now, it is day 5. There are tons of different resources around the Advent of Code in Kotlin campaign that we're running here. And of course, I do recommend that you join our Slack community, which is a great place to hang out with. And especially today, honestly, was also very helpful. If you get stuck, you'll find other like-minded people there who can help you, who can maybe take a look at your code, or you can just see what other people struggled with and maybe don't feel so alone with your struggles. Of course, we also have the leaderboards. If you haven't joined one of them yet, feel free to. Not only does that allow you to compete, it also gives you the chance to be part of a pool of people who might be able to win a couple of Kotlin prizes. That's pretty exciting. And of course, if outside of this stream you want to continue your learning journey, make sure you check out the resources that includes previous solutions, our different blog posts, and even a plugin-based course on algorithmic challenges in Kotlin. There is one very important note that I would like to bring up right in the beginning, and that is that if you are a repeat customer of our wonderful stream that we have here, tomorrow we will be 1 hour later than usual. The reason for that is that the JetBrains AI launch event will happen at 5 p.m. CET. You can convert that into your local time zone there, and we, of course, want to give you the opportunity to watch this as well. And after that, we'll continue with our own development probably without using AI. Okay, so with all of that out of the way, I am really, really delighted to welcome our guest today. Our guest today is Roman Belov. Hi, Roman. Welcome to the show.
Hey, Seb. And hello, everybody.
So, Roman, I asked you beforehand how to introduce you, and honestly, I feel like the appropriate title after what I've seen before would be the Kotlin Notebooks Wizard, but I guess more realistically, you are responsible for Kotlin Moonshots, which is like kind of our internal structure for, well, trying cool new things with Kotlin and like really pushing things forward. Would that be right to say?
Yep. And I'll try to showcase some of our stuff today.
I'm very excited to hear about this, and I'm really excited to have you on the show. Of course, if you folks in the chat, whether that is on YouTube or on Twitch, have any kind of questions for Roman around anything about the cool things that we do in Kotlin, make sure you also post that in the chat, and hopefully we'll get to these points. Roman, have you done Advent of Code before?
Well, previous days, I've actually... Well, first of all, the tasks are very tricky. I mean, like, it's not tricky to solve, it's very tricky to read it. Like, they're long and like very sophisticated and so on. And to be honest, like previous 4 days, I've actually solved, but I did it like in very strange way. I was trying our AI assistant that we're gonna showcase tomorrow. And I didn't only like write any lines of code. I actually didn't even read any lines of code. And actually, and and I managed to solve all the 8 tasks with the help of just AI assistant, which was pretty like cool experiment. Last year, I was trying to do the same with freshly released OpenAI ChatGPT, and like experience was not that pleasant. I mean, like it was quite hard sometimes, and you had to read, understand what's output and so on. Like the progress during 1 year is quite significant.
I can imagine.
Speaking about Advent of Code, I've actually run the first Kotlin challenge for Advent of Code. And it was like, I don't know, like how many years ago, we had a special template in our web demo for Advent of Code. So I was the one who actually started this integration, like collaboration between Kotlin and Advent of Code probably 7 years ago or something.
Wow, that is quite delightful. I do actually, now that you've brought up this cute anecdote, I do need to mention here briefly that the Advent of Code guidelines, one of the parts, I think under the frequently asked questions, is the question of, can I use AI to get on the global leaderboard? And so if you do want to try out your AI stuff on Advent of Code, that is, of course, something that you can try to do. But the point is that, of course, since this is a competition where people try to get better at programming, usually on their own, of course, also our request that you don't use AI tools to like dominate the global leaderboards, and maybe give it an actual like shot yourself. We have this mentioned in the blog post too. But of course, it's always a super interesting thing to experiment with and see what the technologies can do, right? So
I actually did it very late in the evening, so it's not about getting to leader.
There you go. I mean, if you're in a European time zone, it does take the considerable extra effort of doing these things at 6 a.m. in the morning. That's Okay. So with that out of the way, we do have a lot of stuff to go through because I have heard that there might be a little bit of a live demo going on today, and a little bit of live coding. So I don't want to stall any longer, but instead I'll make sure that we open up our problem description here. And of course, before people start to complain, I'll make sure that the hat goes on. It's still not very well suited for wearing over the headphones, but it's close enough. And we will dive into day 5. If you give a seed a fertilizer. You take the boat and find the gardener right where you were told you would be, managing a giant garden that looks more to you like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request. He brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived, and we're having trouble making sense of it. The Almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused by each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. For example, given a couple of seeds and a seed to soil map, soil to fertilizer map, fertilizer to water map, water to light map, light to temperature map, temperature to humidity map, and humidity to location map. We have the seeds listed out that need to be planted. 79, 14, 55, and 13. And the rest of the almanac contains a list of maps, which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the maps describe entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Consider again the example seed to soil map. The first line has a destination range start of 50, a source range start of 98, and a range length of 2. This line means that the source range starts at 98 and contains 2 values, 98 and 99. The destination range is the same length, but it starts at 50, so its values are 50 and 51. With this information, you know that seed number 98 corresponds to soil number 50, and that seed number 99 corresponds to soil number 51. The second line means, I'll make sure we have this on the screen. The second line means that the source range starts at 50 and contains 48 values, all the way from 50 to 97. This corresponds to a destination range starting at 52 and also containing 48 values, 52 through 99. So, seed number 53 corresponds to soil number 55. Any source numbers that aren't mapped correspond to the same destination number. So seed number 10 corresponds to soil number 10. So the entire list of seed numbers and their corresponding soil numbers looks like this. With this map, you can look up the soil number required for each initial seed number. 79 corresponds to 81, 14 to 14, 55 to 57, 13 to 13. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you can find its corresponding location number. In this example, the corresponding types are seed 79 through 81, then from 81 to 81, to light 74 to 78, to humidity 78 to location 82, and so on. The lowest location number in this example is 35. The question now is, what is the lowest location number that corresponds to any of the initial seed numbers? I have to say, this was a mouthful to read. This was quite a long description. But I'm curious, Roman, like what were your first initial thoughts when you read this?
Oh, it's quite funny story. Do you do you think it's a practical task? Do you see any practical application?
That's a good question. Like from the get-go, I wasn't entirely sure, but I actually so personally, the longer I looked at it, for me, the more this was kind of a metaphor of just like if maybe something like a neural network. Actually, maybe I might have been primed with this from our previous conversation. But you just have like a bunch of values that you like feed through a bunch of like different kind of mapping functions and then arrive at some kind of result.
It's funny that when I came to JetBrains, and it was in 2012, and it was one of the first tasks I've actually working on, exactly this algorithm.
Really? For what?
And good question. I was working on memory profiler, which is called .memory. Did you guess it? I'm still not entirely sure. Like what part of .memory what is the most like bottleneck thing of any memory profiling? What is the most important in managed environment, like in JVM, .NET? SAP is garbage collection.
Yeah, garbage collector. Yeah,
and
sure.
Garbage collector works exactly the same. Frankly, it's the algorithm how it works. It's just moves this part of the memory to a new part. Like it's collecting some memory and then it's there is a compactization step, and it moves the blocks. And to actually, when you write a profiler, you have to somehow actually make the same movement in your memory structures to actually understand, for example, what memory, like you had memory in snapshot 1, you have memory in snapshot 2, and then like you have to somehow translate the memory through all the moving blocks from one snapshot to another one, and then you can compare them and so on.
Oh, wow.
And I created a very efficient algorithm based on skipped list. Skipped lists are actually, do you know what a skipped list? It's like list.
I've heard of the term, but that's about it.
Yeah, it's like list, but like it's like has different access levels. So on the last level, it's just list. On the next level, you skip approximately every second element and connect it like a list. And on the third level, you actually skip also 1 second element from the second level and also like connect it as a list. And then you have a structure that allows you very efficiently find like because the problem with list is that to find particular element in list, you actually have to navigate through all the list. And to find it like in efficient way, like using like logarithm of the number of elements, you can use this skipped list structure, and then you can cut it, and move somewhere.
Okay. Very cool. So is your solution today going to involve a skip list?
Absolutely not. It will be way more inefficient.
All right, very fair. But cool. Yeah, for me, I really tried to just kind of anticipate where they were going to go with this, and I was already terrified whenever. So we can actually take a brief look at the actual input here, and we'll see that these are pretty big numbers. Let me make sure I zoom these a little bit. These are pretty big numbers, pretty big ranges. Yeah.
Looks very similar to like actually position in virtual memory, like it's just pointer.
Oh, very good. Yeah, I suppose so. But yeah, I was already like looking at the large ranges. I already figured that something might be up with this kind of stuff. But I think probably the best way of looking at the stuff is to move over into your IDE, and then maybe you can walk us through your approach with solving this. And as far as I understand. Yeah, as far as I understand, you're going to do this with nothing else than Kotlin Notebook, which I'm sure a couple of you folks watching have already heard about. I'm sure you can give a brief introduction of Kotlin Notebooks yourself here in a second, but if you haven't heard of it, stay tuned. This is going to be exciting. So if you're all right with it, Roman, I'm gonna put your screen up.
Yeah, sure. Let's try it.
Good. All right. Okay. So you're visual. You're visible.
Cool. So I've just did a absolutely empty Kotlin project, and I've changed only one word here. And actually, I can run it. I can run it. Hopefully, real. Oh my gosh. Yeah. Oh yeah. We got the result, which is cool. Quite. But like I want today to do it like in a different way. There is a plugin which is called Kotlin Notebooks, and it works with IntelliJ Ultimate. Of course, I'm on the latest nightly version, so it's could be pretty unstable, but at the same time, like it's still very like helpful for me to find new bugs. Hope we find several bugs today. And also, like, to install it, like, yeah, you just find it on Marketplace, install it, and I have it already installed. So let's probably create our first notebook then. So I click Command N and create Kotlin notebook and call it, okay, 5. And let's add it to... What I also need? I also probably need input file. So let's create input txt here. Also, let's add it to our source control, and let's copy the input. And here it is, pretty long one. And I will create one more input, which is actually a sample. txt, which is available in the task description. Also pretty long one, but shorter. Cool. Okay, let's dive into Kotlin Notebooks. And it's very simple, intuitive. So you can just like write the code like you do in ordinary Kotlin file. So let's create, for example, input and yeah, create file and oops, I've actually started the cell. So I need input txt here. So to run the cell, I actually can just click this button, or click Shift Enter. So here it is. Now I have input, and this input is actually like a variable. Probably let's read all the lines from input, and now this variable can be actually printed, and like as a result of every cell after I execute it can show some output. Actually, the last statement is an output of the cell. So here it was unit, so there's no output, and here actually it's just like our input. Okay, let's check probably how many lines we have. Like, okay, quite a lot of. So first we probably need to somehow parse seeds. How do you usually do it? Like it's in the first line, right? So Seb, how to parse them? Let's have seeds, take input 0, right?
Sounds
and then I need the substring after, yeah, some string after, some string after column, because I don't need this part.
Oh, that's nice. So I did that part just doing remove prefix.
Oh, it's funny. Yeah, and then I like, yeah, split it by space. Then let's see what we have at the moment. So, and the cool story about notebooks, you can always see like intermediate results, which is nice. So then I probably need to filter all the empty strings, because I definitely not need them. Filter, it is not blank. And the next last thing, probably map it to integer. Run it. Oh, and I got exception because it's way too long for integer. So let's stick to long. Cool.
There's a really awesome like super quick like iteration cycle here.
Yeah, that's basically the idea behind notebooks. Like have a very quick and intuitive iteration cycle. So we always we don't write the whole story first and then run it and fix and try to fix it in debugger and run it again, recompile and so on. You can do it iteratively, and you're always pretty sure that you actually have a right intermediate result. Okay, so let's probably take a look at it from a little bit other perspective. And for this, I'll show you how to actually use, because I want to visualize these numbers. Otherwise, I can't understand actually how big the difference between them and so on. And for this, I actually can use some visualization library, and it's called Candy. Candy is actually short for Kandinsky. So, and for many libraries in notebooks, which are available out of the box, they actually, all the ordinary libraries published on Maven Central, but for some libraries, I actually have a shortcut. And instead of using it, because we have a longer syntax, like very familiar to you, Gradle syntax, for example, like dependencies, implementation, and then I can show the coordinates of the library here. And then this library will be available inside the notebook. But for some libraries, I have a shorter shortcut. And I just click Use Candy here. And for them, I actually have a nice completion for all available libraries. And actually, you can write integration for your library. We actually will also need data frame later, so I will add it here as well. Cool. Now we have this plotting library. Actually, it's very intuitive Kotlin DSL for printing for drawing charts. So it has like entry function plot. Then I can add like the name of the layer. For example, here I'd like to use bars. And then I can say that x, and x gonna be just like the number in like just number of the seed. So it from 1 to seed count, right? And y goes to actually seed, and it's called seeds, and actually probably I'll rename it to seeds. And see, I actually don't have seeds at the moment because like I renamed it, but it's just renamed and it should be executed first. Now I have seeds, and yeah, cool. Now it's resolved.
But also, I'm very impressed that it works. That you can still do refactorings even across cells. That's really awesome.
Yeah. So let's close all other tabs. We'll need only notebook, and yeah, here it is. So all our seeds. So we have very like very different seeds here. Some of them are with quite big number, and some of them are quite small. And yeah, something like this. Cool. Let's go further and try to parse the rest of my input. So I had input, and I actually passed already the first line of it. And so let's drop it. Let's take a look how it looks. Actually, the second line is also empty. So I will drop 2 lines. And okay, what's next? I actually need to somehow read them, like all the lines. And like we have, like, let's open this file. Yeah, so, and it was input, right? So it has empty lines between the categories, right?
Yep.
Probably we can use it to split our sequence of lines into different categories, and it will be like.
This is a really interesting one, because I remember that this was actually a key important part for last year's Advent of Code, the very first day. And I'm very curious to see how you'll do this, actually, because unfortunately in the Kotlin standard library, we don't have a super nice function that's like split a list on a like splitting element. So the trick back then that a lot of people used was we'll treat the whole thing as one long string, and then we'll split it on 2 new lines as the separator, and then just break it back up into individual lines.
Well, I'll try to do it probably the most like simple and functional way I know. So let's just use fold function here.
All right.
And in this fold function, we'll actually try to accumulate their series of lines, and just like start new accumulator after like we meet the empty line, and it's like gonna then be something like so we need a like mutable list of mutable lists, something like this. Mutable list of string, and then we can just like have this accumulator and our current string, and then we can actually, yeah, so if current string is blank, then actually we need to like add new accumulator, start new accumulator. So we just add a mutable list of string here. And else we'll add the string to the last accumulator. So add and this string thing. And we need to return the like updated accumulator. So something like this. And yep, now we have like the list of lists of string, but now they are splitted based on empty strings.
That's actually, you know, this is and Johnny here agrees with me in the chat that is a clever approach. For some reason in my mind, when I start doing folds, I'm always like, okay, I'm in the functional realm, so I should do everything using like immutable things. Like I should also keep all the lists immutable and such. And then this kind of gets a little bit out of hand.
Yeah, that would be a little bit tricky, but also possible. But I've tried to like write the shortest code probably. And given that we are not actually like bother here about like the performance, we just need the result. So like let's stick to it. Okay, so now let's transform it to something like which consists of these maps and try to parse the maps as well. And for this, I probably create several like data classes, because with them it will be more simple to understand. So I'll probably need block. And actually block, it's like moving block. Yeah, it's like from, let's say, garbage collection term. So it's something that has source address, then okay, and I'll probably have to say that it should be long, then destination, and it should be long, and length, and it should be long as well. And another thing which I need probably is actually the map of this stuff. And for map, I need to like from what to what, from seed to soil and soil to and so on. So let's call it from, and it's string, and let's call it to, and it's string, and actually we need just like a list of blocks, right? So blocks, and it's just a list of block. And we found our first bug here. Yeah, cool. And it should be value probably. Yeah, cool. Now we have all the classes we need. So let's now parse our string into these classes. So let's first like take our first line and parse it. And what I need here, actually, yeah, so it's going to be something like it. And let's take a look at it. So I need to split it based on hyphen. So it's I split mutable list. Oh no, it should be first line first, right? Then I can split it based on hyphen, and I don't know, probably also space by. Okay, I don't need it. And then actually I can create some variables here. So I will need from and to, and actually I'm meeting these two using this underscore. So using this destruction and declaration, now we have from and to from this first line, right? And all other lines are pretty simple to like parse. It should be, so we need to drop the first line first, right?
Yeah.
And then for all others, we need to just like map it and just read and split it based on, so it should be split it based on space separator. and then convert it to long. I don't know. Probably we have too long on the collection as well. No. And yeah. So and what we have here is, let's call it. So it was. I have to check the. So the first is destination. So it's vice versa. Destination, then it's source, and then it's lang.
One of our viewers here brings up a good point. Rob brings this up. So the way you're doing this, the to part is still going to have the word map in it, right? Is that intentional?
Sorry?
So when you look at your from underscore and to, that destructuring, it's going to be seed, and then the second part is going to be soil map. Like it will still keep that the word inside, right? Because it seed to soil map.
Correct. Thank you. Yeah. So yeah, let's also use the space separator. Yeah, then it's gonna be seed, to, and soil. Cool.
And yeah, I really like this. This fix is kind of fun as well because it uses the fact that these are positional arguments and you don't have to match everything. So essentially now Roman just kind of like excluded, like he created one extra element and then just ignored it without doing anything. It's like having another underscore at the end.
Yeah. So yeah, now I can actually create our block from it. Hopefully, yeah, here we already have right order, source, destination, and yeah, and finally I have to create this like, let's rename it, by the way, this map, because I don't like the name map because it will clash with other maps. So let's call it seeds map. And yeah, let's create a seeds map here, and it should be from, to, and blocks. And blocks are actually, yeah, we need to create a variable for it, right? Blocks. And I'll just delete this one. Cool. So let's see the result. We have seed map from, okay, let's take the first element. We have a seed map from seed to soil and lots of blocks, and blocks looks nice. Yeah.
All right.
Cool. We did it. So we not just like call it somehow. For example, I don't know, like, okay, let's call it maps. And yeah, we finally parsed our input. But the story is that input is very, very, very complex. And it would be really cool to somehow like visually take a look at it to understand how it could look like. And we'll try to use the same Candy library here. And let me show probably some examples of what actually Candy can do. Let me find it. Oh, I've actually closed it up. Okay, doesn't matter. So let's then try. Okay, now I want to find it. I want to show you. Candy examples, cool. This one. Oh, now I understand why I lost it. Okay, here it is. Now we have two. Yeah, so it's like we plan to show the the first preview of Candy relatively soon, and it's like pretty versatile library. It can do quite a lot of cool stuff. And for today's task, we need ribbon. And ribbon is actually just like a kind of a stripe that has x coordinate and x minimum and y minimum and y maximum to actually and it's gonna be our moved block. Okay, so let's switch back to IntelliJ IDEA, here, and let's try to understand how to do it, because we need to make some preparation first to understand how the candy works. Usually candy works with a little bit prepared data, and we need just individual elements. So we need a separate block for every moving block. So, and this block is individual ribbon on the our chart. So let's try to do it. And for this, I'll try first describe what I actually want to have. So let's call it draw block. And it will be very, very similar for what we have in our current block, but a little bit different. So it's actually should have, of course, some coordinate from and it's starting. So it's just going to be string, and also we need low and high for this. So it's it's even not block, it's range. Yeah, so it's range which is along the y direction. So we need string here, and we need from, and we need lower, low, low, which is long, and we need up, high. Let's better call it high, which is also long. And given that we have lots of these blocks, I will also add block count and block number, or ID. Let's call it ID. And ID is gonna be just integer. And I'll explain why we need this ID a little bit later, but it's just to somehow distinguish these blocks from each other, because they all going to be very similar, even for one coordinate, x coordinate. Okay, now we can actually take our maps and try to map them to these drawing blocks, draw, how it's called, draw block. Why it's like this? Draw block. So for this, I actually have to take every moving block we have. So I will iterate through all of them. I will have a map and take it blocks and iterate through all the blocks. So I will also map it, and I'll take this and every block. Actually, it's just two blocks, on the left side and on the right side. So it's two ranges. So on the left side, it's gonna be a draw block, and it's I need some ID here, and I just and never do it like this, kids. I just added some index here, and so I actually needed it let me check it, it's block, and here should be a string comes from each. Oh no, it comes from, so we have two its now. So let's call it block. So then it goes it from, right? And it goes block src, and the upper high should be block src plus block length. So what I did, I actually described the left range here. The same I will do here. So, but it will be now 2, and this is going to be destination, and this is going to be destination. And important that they have the same ID. That's why I need ID, like, because it's on the left side, on the right side, they are like the same. So, and I will add it like, and here I will add it like, increase my index. That's it. So what I have right now, I have lots of, okay, I need to flatten it, right? So I need to flatten, and actually, yeah, actually I returned to the last one. So here should be something like a list of, right? I need 2 blocks and something like this. And now I have list of pairs, and I like will flat it the second time, or I just like flat the map here. Cool. Now we have like the list of draw blocks, but they look a little bit like weird, so I will convert them to data frame. And hey, I already have like very simple representation of it.
That is so incredible, I gotta say.
ID. And yes, I have seed, soil, and actually low, high. So I actually converted my like thing by like splitting it into individual ranges. Like very simple thing. But now let's call it somehow. Okay, val, oh, several more bucks. And okay, like let's call it blocks for drawing. Yep, it still works. So now let's actually, yeah, let's take a look at it one more time, and let's try to visualize it. So blocks for drawing and plot it. So this plot is now works in context of this data frame. Data frame is just a table. Don't be afraid of it. It's just like a simple table. So, and I need this ribbon thing. And this ribbon thing is actually now should be mapped somehow. So I will X go to like, and how this called from, right? Low gonna be, oh, it's not low, but y minimum. Let's go to low. And y maximum, put it to high. And let's take a look at the result. Pretty cool, but not exactly what we need. So what's the problem here is actually that we need to group all the stuff by actual like block number. So if I do it like this, so I need to group by it by ID, which we have, and put it like this. And wow, now we have the exact map how all these blocks are moving. Let's make it a little bit more fancy. So first of all, I add some like color to it. And let's say our color gonna be, for example, map to ID. By the way, have you like noticed that now all this stuff that we actually created, like from ID, high, and so on, I actually can be addressed right from the DSL. And it works the same way, like the following way. Like when I created this block for drawing, it's data frame, and this data frame actually have columns. And for each column, when the data frame was created, we generate on the fly extension properties, which actually help to address it in strongly typed manner. That's why we have like strongly typed DSL here. And at the same time, it's like pretty neat. And we can, for example, like I'll show you later, add more columns, and all these columns gonna be like also can be addressed with the help of like this extension properties. And that's actually a really, really cool power of like Kotlin notebooks, Kotlin kernel, and our approach. Cool. Now I have like lots of like things here, but I'll probably want to, for example, map it on low like this. Way nicer. And probably let's, for example, like change the scale, like the way how we transform the value to actual color, and it's called scaling of the property. So for example, let's use this. So, whoa, nice. Now it's a rainbow. And also, I really don't like the borderline. It's so weird. So let's, for example, like change this there, like it like this. Nice. And change the alpha thing, for example, to see the through our blocks. Cool. And for example, change the like the size of this thing. So I can go here and change the layout size and say that, let's say it 1000 to, let's say 500. Yeah. So now I have all moving blocks, and now I understand like how my seed should go through all these pipes. Sebastian, you were showing us some like funny drawings that when you tried to actually, does it look similar?
I'm sorry. I'm honestly I'm a little. First of all, I can see now why the library is short for like like Kandinsky. I mean, go. I'm super impressed by. First of all, I love this. Like, I'm not sure. Someone actually already said this. Sebastian is fascinated by the coding. I don't think there have been many times where I've been so locked into this, because there's, again, the speed of iteration with which you're doing this and the very visual output is mind-blowing. And yeah, looking at, like, I'll hold this into the camera again. Looking into the stuff that I drew just earlier today, there's quite some similarities here, I think.
Oh yeah. So, and
like I drew 3 like ranges, and you of course managed to do all of them.
Cool story that we can, for example, now say that let's read sample instead and just run all the cells again. And now we have like it's for our sample.
Wow.
So,
I'm
and
most
it's way
honestly
more understandable.
One of the things I think is probably most impressive about this is just the ability of also just sort of quickly iterating on the styling. Like you took your data, you transformed it like very quickly. What you got out of it with data frames was already an interactive representation, and then you turn it into a visualization like this, like within minutes. It's genuinely it's a different type of superpower.
Yeah. So, and actually, the cool story is that we can now analyze it. Like for instance, here we can easily understand that these ranges are not random at all. One of like the questions I had, are there cases, for example, when like several ranges are actually mapped to the same range? Like, because it's like pretty possible based on the format. And actually, if we take a look at it, it seems the input is not random. They try to preserve the like kind of that it can be mapped vice versa. So it's like which is called biaction. So And yeah, so let's switch back to our input. And cool story also, like you can always restart the kernel as if you start from the beginning. So I've restarted it, and like now I'm run all the cells, and hey, we have actually a reproducible result, which is cool.
Wow.
Okay, so next thing, we need to actually somehow actually take our seed and like move it along these pipes. And yeah, let's start. So for this, I'll probably need, let me think, how we're going to do it. Okay, I have like one idea. Let's actually try to do it using data frame library. So I will take seeds, and this seeds is actually a collection. If I convert seeds to data frame, it's going to be a column with a name value. Okay, I actually can rename this column. So let's rename value into seed number. Cool, now it's seed number. And by the way, like something that I wanted to show you, so let's call it seeds data frame. And now this seeds data frame actually has this seed number column, so you can address it. For example, you can address it like this. For example, let's take all the seed numbers which are higher than 1 million, and it works. Very simple. Okay, 10 millions. Yeah, it's still quite a lot of them. Okay, smaller. Yeah, just 8 now. So, and it's like, yeah, and it's still, so I can't, for example, write it like this, because it's like seed number is like actual number, it's long, and here's our extension property. So it's on the fly analyze like the properties, like not properties, but yeah, properties of the original data frame. Okay, now we have this original data frame, and let's actually now use our moving blocks and fold it with this data frame. So I will take my maps and fold it, and I will use my data frame as accumulator. So here's our data frame, and I need now to write on every stage of this folding, I will add a new column to it. And let's call this, okay, accumulator should be defined here. Yeah, right. And what's wrong with it?
I think you also need an element.
Oh yeah, okay. Yeah, so I need to. Okay, let's add, and let's call the column basically how this. Yeah. So we need item. Yeah, so like how this map is actually called, not 2. Yeah, 2. The right one. And then I need to like show how to calculate this column. And that's going to be a little bit tricky, but okay, let's try. So we need to take the last element in the row. So to like, we are now currently in row context. So we need to write a calculation for like every row. We calculate the next value in this new column based on all other columns here. And we actually can, okay, let's call, by the way, it's seed. And we can actually do it like this. So we take this row, and take the value from map from, and we call it, let's say, from. And currently it's any. So let's, here we should like show that it's long. And next we actually can do like the simple thing. So we can like iterate through all the blocks in this map. So for block in map blocks, I will just like see if the from value is inside block. So this from, is there some intersection library, standard library function?
I don't think so.
Okay, so let's just like say that it should be bigger than src, right? Or like this. And at the same time, it should be smaller than block src plus length. So it basically means that we are in the range on source range, right? Should it be like smaller or equals? If it's 50, for example, then 151, most likely yes. So it should be like this. And then we need to return like the updated block address. So it should be from plus the actual difference between src and destination and block src.
Someone does mention that potentially you could rewrite the bounds check by first creating a range and then using in with that range.
Yeah. That's actually, yeah. So we can actually say that from in block src range. Yeah. More or less the same. So it's going to be something like this. Yeah. So from in like this.
Yeah.
Cool. And yep. So let's run it and check the result. It works. Like, I mean, we literally have now seed, soil, and all the columns. And like every seed is now like actually translates through all the stuff. And it's like very easy. So to get the actual result now, like we need just to take this seed data frame and take minimum in the last column, which is called location. Yep, we did it. But it's like definitely not all. Like, let's try to draw it somehow, because it's very interesting how our seed is actually traveling. So let's take our seed data frame and let's try to draw it somehow. But actually, to draw it, I want to draw it as a lines. But to combine it like into lines, I actually need to actually have all these columns actually called like the proper way. So I will like gather, like, I mean, like these column names should be now values of the data frame. So I will like gather on all the columns we have. And now I actually have like seed and value, soil and value, and all this kind of stuff. So I actually just gathered it into one table, which now can be like actually let's call it somehow like to draw. Okay, seeds to draw. Cool. And now this seeds to draw can be plotted. And for this, I will again use Candy. So just like Sits to draw, gather. Oh, this gather thing actually, because these columns are actually now called key and value, but like it's intermediate representation. Like, I mean, like we also have to somehow call it properly. So let's call it stage and value. So yeah, now I have stage and value, and now it's like actual data frame, so I can plot it finally. And I will actually need to group it now by but by what? Oh, it's a funny thing, by the way. Like here, let's try to call it to draw it. So I will code line x spec. Oh, sorry, x how we call it? Stage, right? Stage, and y is value. Oops, nope, value column. This one. Cool, but again, it should be like the lines should be somehow like different line for different seat, right? So we need to actually somehow probably gather it, but also like let's introduce one more thing here, and we add ID. So we add ID now. And now we have this ID column, and we will gather for all except ID. Cool. Now I have something like, let's see how it looks like. Seeds to draw. Cool. Now I actually have also ID for every pair of stage and value. And this ID is actually like different for different seats, right? So now I can actually group by this ID, group by, oh yeah, ID. And now it should be correct. Cool. And here, like, let's add some colors to it and color them obviously based on ID. Yep, we did it. So now we have all our seeds traveling along these pipes. And for example, like this one, the smallest one, yeah, so we can actually even understand how it's and where it's appeared in what part of my original seeds. I have something weird with tooltips now. Okay, I found one more bug. Cool. So basically that's it. I believe that's like a little bit different approach, and it's not like how this task actually should be solved. There are faster ways, I know, but I guess it's like something that at least I tried to show and learn you some new stuff.
That was genuinely incredible, Roman. I think that was a real delight, and we've had a lot of people say that they've really enjoyed this, and we've also had a lot of questions come up, but I didn't want to interrupt you, so we can probably get back to those. But yeah, once again, like my mind is always blown, because for me, for the longest time, it always felt like the notebook stuff was kind of reserved to all typical data sciencey languages, like maybe Python or maybe R or something like that. So seeing this in a language that I speak and I can make sense of, and where I can understand the way that DSLs are structured, and then I have type safe accessors for things, it's truly impressive. It really is.
Thank you, Seb. Thank you. And I actually was also very much surprised how easy to actually solve all the advent of code stuff inside notebooks and play with it and so on. I actually was a little bit insincere in the beginning. I actually tried our AI assistant together with it, but sometimes I try to then play with it a little bit. and so on. And for example, to do some visualizations and like all this kind of stuff. So yeah, Advent of Code is amazing puzzles where you can learn new things also, and not just compete for the leaderboard.
Yeah. I've said this in all of the previous streams that there's no better opportunity to learn something new and like build out your skills, whether that means trying a new IDE, like running the stuff in Fleet, for example, or doing Kotlin notebooks and trying a completely different approach for like interactive programming, or if you're new to Kotlin, just kind of trying the language for the first time. So at this, I think this was the perfect demonstration to see how these problems present a wonderful playground to try something new.
By the way, I see the question, not the question, but probably comment from Jonathan. And he said the REPL part is nice, but I'm not sure if I'll use it. I like my helper classes. And the cool story is that inside notebooks, you actually have access to all your code. So here, like, you can actually select your module and select, for example, this like main module, and actually have access to all the classes and functions are defined in your model. So notebooks is not like a separate plugin, separate tool. It's actually a companion and reliable companion for you inside your project, inside your notebook, and so on. So it's not a separate thing, which is actually the power of having notebooks right inside IntelliJ IDEA.
Yeah, it allows you to explore the existing code that you might have in projects in an entirely different way. I remember when I was doing the videos on notebooks, which you can also find on our Kotlin YouTube channel, in case you want to click around.
Amazing
there
video, by the way.
Oh, I do appreciate it. I don't think I show visualizations quite as visually appealing as this one, but I do show that you can use, for example, classes that I had a Ktor application that was doing a couple of things, and you can just pull in those classes into your Kotlin notebook, and then you can work with them the exact same way as all the other type-safe accessors, which is really, really cool. So there's a couple of questions here that I'd still like to bring up. But first of all, and I've already put up this comment beforehand from Zelt, which is, holy hell, that's like NumPy or other comparable things, but with strong types. I love it. And then Patrick asks a very good follow-up question, which is data frame also programmed in Kotlin, or is it just a wrapper around the C and C++ implementations that are popular in Python, for example?
Kotlin data frame is completely written in Kotlin, which potentially like we can make this library a multi-platform. And what is very important about Kotlin data frame, because you can actually store Kotlin objects inside like your columns. So it's not just like a table with primitives. Because like if it's a C++ implementation, you can't actually pass like your objects there and so on. So it's like really something that like it's very similar to standard library in some aspect, but like on the other hand, it has completely different paradigm for like structuring the data and so on. I actually can show one more thing regarding Kotlin data frame, which is also pretty fascinating. So, for example, let's take this seeds df and let's group it by ID. And well, we actually have like group inside the like cell. So it's like every cell can like have a data frame inside the cell. So it's actually, you can like dig into and like take a look like what's inside, go back and so on. So here is actually like, okay, it's probably with seed.df, it's not that funny, but if we take seeds, seeds to draw, then every group actually contains of a separate data frame. And you can navigate through this structure Or for example, like you can group columns a little bit different way. For example, let's take sysdf and group columns which starts with letter S. And yeah, now I have actually, and like, yeah, so let's call it somehow S calls. And yeah, I have now a column which actually S calls, which has subcolumns which seed and soil. So I can like see it like in this way, and it actually gives you ability to have like different kinds of hierarchies in this data frame, which is like, you may say that it's a madness, but it's actually not, because if you take any, let's say JSON, it's exactly this structure. So you actually have object, and objects sometimes have sub-objects, and if it's sub-objects, it's actually like nested columns. And sometimes it has arrays. And if it's array, then it's actually data, and sometimes it's array of object. So like it's a array of objects is actually a data frame, and that's why we have like nested data frames inside some cells. So if you take a JSON, you can convert it to data frame without actually losing the structure of this thing. And what is really cool, you can then, for example, address it in the same way. So let's call it grouped. And now like this group thing actually can be addressed like as calls, as seed. So we preserve the structure and like in this generated extension properties. And
Wow.
when you're used to it, it's like amazingly useful.
So do I understand correctly that this also? So I could also just like take an actual JSON and I could put it in here, and I would get the same kind of access it generated for me.
Absolutely. So
that is so cool.
And, like,
so because actually, yeah, I had this. I know that one of the classical things for pulling information out of JSON is like a JQ or these like JSON path things, and I always found them a little unintuitive for me personally. But now I'd like with this on my like at my fingertips, I now have a good idea that I could probably just use that for my data exploration tasks, even if it's structured as JSON already. That's awesome.
Yep. So if we compare Kotlin data frame to like pandas or another data frame implementations, well, it's very advanced in terms of like how it can be used for you as a Kotlin developers. It's basically made for Kotlin developers.
And I think it really shows this off. I do remember actually that we also had a couple of talks at Kotlin Conf that already showed off some parts of Kotlin notebooks or the Jupyter kernel. So maybe check that out as well if you're thirsting for a little bit more notebooks content after we're done here. There's a couple more questions here. I think one of the very fair ones is it available in Android Studio or in the community edition of IntelliJ?
Not at the moment. So it's available currently only in IntelliJ Ultimate. There are technical limitations, which are quite hard to relax. We rely on some platform components, which are available only in Ultimate Edition.
Okay, fair. That makes sense, but it probably also makes sense to let that people. I really like the metaphor of programmable Excel. I don't know if that's something that will resonate with people or whether it will scare people, but I mean spreadsheets are quite powerful. Great. Let me just see here if I've missed
there was one more question, which is, I believe, very important, and it was like something about like if this Candy library is available outside of Notebook.
Yeah.
And actually it is. So you can use it outside of Notebook, and it can render to Swing. it actually can, because this Candy library is actually a kind of neat Kotlin idiomatic wrapper on top of Let's Plot library, which is developed inside JetBrains, and it already used to have Kotlin syntaxes, but very similar to R syntaxes, which is was very hard to use in Kotlin. So we created a better abstraction for it. And also Candy actually can be used with other drawing engines as well. But currently the most advanced engine is this Let's Plot library. And it can render to lots of formats, for example, HTML, SVG, PNG, Swing, JavaFX, and probably Compose multi-platform. So it something that can be very interesting not only in notebooks.
Yeah, it definitely piqued my ear here when you said Compose multi-platform, and indeed we also had someone say Compose Candy would be great. And I truly do think that having such a plotting library is an absolute superpower. There was another question, which is also an interesting point and probably needs a little clarification, because we have seen these interactive visualizations of data frame. Is that something that's part of the library, part of notebooks? Can I use data frames to do the same kind of visualization in Kotlin multi-platform or on Android or other platforms?
Yeah, this fancy table is actually a part of platform, IntelliJ platform. So you can't use this particular visualization in your KMP project, but data frame, for example, has also HTML version. So you can write to HTML, and actually, you actually have a HTML version of the same table. It's not that fancy, so you can, for example, sort the columns, you can rearrange them and so on, but it's still pretty usable. Or you can actually just probably say to string on it, and even to string works pretty nice. Or probably we have something like print, and let me check. There are some something like borders true, and actually this is it's not that visible, but it's actually something that you can insert into your markdown, and it will be rendered properly in your markdown. So
Patrick asks, can you also do describe?
Yeah, sure. So you can write describe, and now we have all the columns, their type, number of uniques, number of nulls, and all this kind of stuff, minimum and some statistics. Wow. Maximum, minimum, medians, and all this.
That's honestly, I'm honestly struggling doing the Q&A because I'm still so in awe. It's truly impressive. Yeah, Sebastian is fascinated by the coding part. It's still very true. All the way to this point. And Boba also mentions again, Candy also does have HTML renderers, and you can even save the plot as an iframe. So that's also very useful. That's cool. Wow, sweet. So is there before we move on to part 2, which don't worry, we're not going to spend quite as much time on, but we did have a couple of people. First of all, a lot of people spend a lot of time on part 2, including myself today. So it's worth looking into. I'm just wondering, is there anything about posture time check? Is honestly that's a very good point. I certainly need to straighten my back a little bit. Is there anything you still want to talk about on notebooks, or something that you still want to mention?
Not really, I think. Yeah, so we actually can, I think, go to the second part.
Okay, awesome, wonderful. Oh, actually, there's one question here still, which is, can you mention a little bit about the performance? I guess you've already mentioned that it's all written in pure Kotlin, but I think it's a fair question to ask. How does that compare to a C++ implementation potentially in other languages?
Well, we've compared it with pandas, and it's more or less on par. I mean, like sometimes it's a little bit faster, sometimes it's kind of slower, but there are no like dramatic changes in speed. I mean, like, okay, it sometimes could be twice slower, but in many cases you just don't care, like, but not more than twice slower. Sometimes it's a little bit faster. So more or less like this. In terms of like, there is one like thing you have to have in mind regarding memory, because in terms of memory, there is, we have a question about it. So current implementation is not very efficient in terms of boxing, because actually all the like objects now boxed, so we don't have like specialized columns of primitives. And that's basically very, like, on the one hand, GVM is very much like efficient in terms of optimization of all of the stuff. On the other hand, we are waiting for like this famous project which will eventually give us like better value classes. On the third hand, actually, like, it still could be a problem in like for like big giant data frames. Yep. So like in terms of memory, there are some like notable footprints. In many my practical cases, I've never noticed them. Like, I mean, like I usually use it for data analytics. I like often like play with data frames more than several gigabytes, and yeah, it's more or less fast and reliable.
Wow, that's awesome. That's really great, and I think those are probably the ranges where most people will be working with things. Like if you're exploring a smaller data set or a regularly sized data set, you probably already get away with that pretty well. Okay, well, I think we can move on. So I'm just going to switch over to my own screen again. And we'll take a look at part 2. So we'll take a look. Hat is on. So let's see what we have offered here. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. So in the first line of the example above, this line describes 2 ranges of seed numbers to be planted in the garden. The first range starts with seed number 79 and contains 14 values, 79, 80, and all the way up to 92. The second range starts with seed number 55 and contains 13 values, 55 through 67. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. And in the above example, the lowest location number can be obtained from seed number 82, which corresponds to soil 84, fertilizer 84, water 84, light 77, temperature 45, humidity 46, and location 46. So the lowest location number is 46. Consider all of the initial seed numbers listed in the ranges of on the first line of the almanac. What is the lowest location number that corresponds to any of the initial seed numbers? Excellent question, and I did puzzle myself with this one a little bit. We can actually just jump straight into my implementation here to have a quick look. Let me just make sure I don't open up any spoilers. which is, so we can take a very brief look, so just so that we understand how I solved the first part of the challenge, because then you'll see that the second part isn't all that different. There's a bunch of parsing logic here, which we're not going to get into, because that essentially just turns everything from our original text into these match range groups. That's just a container for essentially like the individual ranges. Once you have that in just regular Kotlin code, no notebooks, what you can do is for a single seed, you can put that in one of those maps, see where it lands afterwards. This function, of course, taking care to make sure that if no value is hit, you just map the same value 1 to 1, and then like essentially forwarding through all the layers that you have. This is probably pretty intuitive to understand at the point where you've seen Roman's wonderful visualization. Otherwise, you would need to make use of something like the stuff that I've drawn earlier today, which is these kind of like smaller diagrams. So each of these like segments are paths that an individual seed can take through the different types of map. I used to call them like layers and like layer ranges because it kind of reminded me of like a neural network, where the data also flows through the individual layers. And now people asked me, or a lot of people said, how do you do this for multiple seeds, for multiple ranges? And a lot of people mentioned that their solution runs for 30 seconds or 2 minutes or so on. And I'll level with you. The implementation that I built this morning, it does exactly the same thing, or most likely it does exactly the same thing that you do, which is it literally goes through all the seeds in all the ranges, even though those are when we look at the actual implementation here, those are pretty long ranges. Like these are pretty big. But I did a back of the envelope calculation. So I summed up all the numbers as to like how big these ranges are, and I just ran a loop that would just increment a counter that many times before I even started rerunning anything to get an idea of how long that would take. And that still completed reasonably within like a couple of seconds. So I'm like, if that completes in a reasonable time, and I know that my algorithm, which is just like 6 map lookups in a row, if that is essentially linear time, then I can probably get away with doing this. But of course, I didn't want to wait, just like exhausting a single core of my machine. So instead, what I did is I just sprinkled on a tiny little bit of Kotlin coroutines, which allows me to make use of asynchronous, concurrent, and in this case, parallel programming. That's a matter of like just adding the Kotlin X coroutines core library, and then what I can just do is I can start a part of code that will be started on the default dispatcher. So it'll be any new coroutines that I start will be distributed on a number of threads equal to the cores in my machine. In my machine, I have 12 cores, so I wanted to put those to good use. And then all I can pretty much do is for each of the ranges that I have in my input, I'll start a new coroutine, and I'll compute the smallest value for that specific seed range. I can then, so those will all run in parallel, and if I can actually run this, so you know my computer doesn't get too comfortable and actually does a little bit of work as well. So we'll have this run here, and oh, sorry, that was the wrong. Oh, I'm sorry. I currently have the example, the example code snippet. That one, of course, terminates very, very quickly. Let me just briefly add the real input here. It will just take me 2 seconds. Here we go. So we'll start this process, and you'll see that it has started a number of things for this range, and my computer is perfectly happy baking on all 12 CPU cores, just trying very hard to compute this solution. And that's an approach that is valid, and that, as you'll see, at least on my machine, will terminate within a reasonable-ish time. I'll probably take a minute or so. But of course, typically, that is not how you would solve this problem. I am very glad, though, that I managed to get away with this, because I'll also admit it took me quite a while coming up with a much more performant solution. The concept of it, like in theory, it's not that complicated. Because instead of running a single individual seed through the whole system, what you can do is you can essentially run a whole range of seeds through the system. So instead of doing a long, you would do a long range. Then the thing that you have to do is at each layer of your kind of mapping structure, so where you map from seeds to soil, or from soil to fertilizer, or from fertilizer to water, you have to make sure that you very carefully split your range in up to 3 different parts. So this is kind of what I have here. You have some kind of input range that comes in, and then you might hit 1 or 2 or 3 or maybe 20 different type of smaller mappings that split your input range. So in this case, a couple of the top elements in my range would move to kind of this red part. A couple of them actually don't touch any of the mappings, so they'll just be mapped 1-to-1. And a couple of them run through a different one. What's important to note here is that my drawing up here was a little ideal case, and of course Roman has already shown very nicely that indeed the actual mappings are a little bit more chaotic. I did come up with 2 examples of slight chaos in my own example, which is if you have a mapping that looks like this, it might be that 2 ranges kind of get switched around. So you'll have a mapping that was previously quite high in value and is then lower than other values. But you might also have it that multiple ranges actually collapse together or overlap in a certain way. So this is, of course, this is the slightly faster approach. This is the much faster approach, because instead of running a couple million seeds through the system, now you only have to run the 6 ranges. So you'll just run those 6. You'll see here that, by the way, that my process has completed in the background and my CPU has slightly calmed down again. So while that is a great approach to kind of hack around the constraint of it being a time limit thing, and we can take a brief look at my implementation. I will say that my implementation is by no means a great reference implementation, but it is something that I came up with by my own, so that's what I'm comfortable presenting with. Werner mentions that you can also just reverse the mappings, which is a lot simpler, and then you can do a binary search. In case you haven't posted your solution yet on the Advent of Code Kotlin Slack, on the Kotlin Slack in the Advent of Code channel, make sure you do that. I'm sure other people will be quite interested in that as well. We'll skip over the parsing code because we're way over time. But generally, instead of running a single seed through the actual solution, or through the actual, we'll call it the gauntlet, the different kind of mapping layers, instead you can just take an entire range and kind of feed that forward 1 layer. So this operation is equivalent to kind of having a single range and then moving it through, in the process creating maybe multiple new ranges. So you will see that as you continue with this, your list of ranges that you need to process becomes becomes more and more complex, or it'll become bigger and bigger. The real challenge here is honestly that in the Kotlin standard library, we don't have super great functionality for checking whether ranges intersect another range, removing subranges from a range, or checking whether a range is entirely contained within another range. And that's kind of where the trickiness comes from. Obviously, the classic thing is the more code you have to write, the more like tiny mistakes you can make. You might make it off by one error. You might switch around a last and a first, or something like this. I resorted to doing like tiny graphics to help me spend as little time as possible trying to actually, or spend as little brain power as possible having to keep in mind the different behaviors. You'll see that also my implementation comes with a lot of very long, strings on the implications and caveats, because it's much easier for me to program. But yeah, the overall idea is you take one range in this feed range forward thing, and it's going to you're going to essentially pump it through all the ranges in the layer. A couple of them will be entirely empty because they'll be ignored. If we go back here again, this range has absolutely no intersection, so we don't care about it at all. If you have a value that is not being that doesn't hit, or if you have a subrange that doesn't hit any mapping, then you'll just keep that in, and that will just be a one-on-one mapping. I really like the idea of kind of taking the light analogy, right? So you think of it as having a kind of a mask or some kind of blind in front of it, and some of your elements are not gonna be covered by this blind. They'll just be passed through immediately. And if you've done like any kind of like set theory or whatever, you'll notice that this is just like you'll just subtract all the different masking elements so that you end up with what is here, for example, the yellow line. Once you've done that, you need to do a little bit of fancy things to actually move everything through the other layers. I do that in 2 steps. First of all, I figure out which parts of my input range overlaps with the mapping range. So in this case, I figure out which part of the red overlaps with the mapping range that I have up here, which transforms values up. And then once I've done that, I just apply the offset that is associated with that layer range. So that means actually like taking the values that I have here and like actually shifting them upwards so that they move along this side. I also make sure that there's no empty ranges anywhere here, which is just nice, because otherwise your debug output is going to be very cluttered with a lot of different things. We're not going to look too much into intersected by and offset by, because those are pretty simple functions. I will say though that you can probably see that in my code here, there's a lot of things where I check that certain elements aren't empty, that the number of elements that I have prior to my conversion and after my conversion have the same length, so that I don't accidentally lose elements, or that I don't have any overlapping ranges. All of which are common pitfalls that I fell into, and that other people might also fall into. This is also one of the parts where I thought it was really, really useful for when I was writing those kind of elementary operations, to make sure I had a little bit of test coverage. Because again, the thing that scares me the most is having a bunch of +1s and -1s and not being entirely sure whether those operations that I'm then building other abstractions on are actually any useful. Werner just posted his solution on the Slack channel, so that's awesome. If you're interested in that, feel free to check it out. Thank you so much for sharing that, Werner. That's awesome. Yeah. Essentially, this is the entire logic. It took me a couple of hours making sure, though, that all the offsets are correct, and that all my elementary functions behaved exactly the right way. as I can tell here, a couple of other people have taken a quite similar approach, which is, I've done the same, but all in one big monster of a function. I did that first, then had not figured out the splitting, gone to brute force. That took too long for my taste, and I finished it. That's perfectly fair. And for these types of huge data processing tasks, functional programming, mapping, filtering doesn't seem to resolve the problem efficiently. That's a very interesting point. I think, again, this illustrates that the choice of algorithm, because I can run this one, and you'll see that even on the big input, it terminates practically immediately. The choice of algorithm is much more important than actually your choice of data structure in this particular case. If you can avoid iterating a million different or a billion different items and rather just have a couple of them, that's a much, much smoother way. So the trickiness from this one really just comes from the fact that there's a lot of code that you need to write and a lot of offsets that you need to make. I also personally had a little bit of trouble because I found out that I had a couple of cases where my own code was working fine on the example project or the example, and then it wasn't working on the real output. And on a friend of mine who I've been talking to throughout the day, who implemented this in Rust for his challenge, for him, interestingly enough, his own puzzle input got the correct solution, but when I sent him my puzzle input, we actually figured out that there was something broken, and he got partially lucky. So that was, of course, also something else. With this one, I think Efemient also added this in the Kotlin Slack, where they said that the chance that you'll hit a couple of off by one errors is a little low. Personally, I have to say I found that a little frustrating because when it's a little non-deterministic, that's always problematic. But these things happen. Werner says, I feel a hint of reversing the mappings was in the puzzle itself because it contained the destination first and then the source, the encoding of the mappings. I mean, congratulations to you for discovering that hint as well. I'm sure it's a good move. And personally, once I have regained a couple of brain power cells and maybe had a good night's of sleep or a meal, I'll definitely take a peek at that. All right. I think we have spent more than enough time on this problem. So, Roman, I just want to say thank you again so much for coming on. It was really appreciated. I'm still glowing. I'm still hyped up from that demo.
Thank you for inviting me. Thank you, Seb.
If you want to try Kotlin Notebooks yourself, make sure you get yourself the Kotlin Notebook plugin, which is available in IntelliJ IDEA Ultimate, and take a look at all of these things. The Candy library you can also try either in notebooks or independently off them. So make sure you take a look there. And I suppose the same thing goes for Kotlin Data Frame. I probably should have pulled that up before. Here we go with Kotlin Data Frames that you can also use in your projects. Awesome. Well, with that, I would once again like to thank you for choosing to spend your evening or afternoon or whatever time it is with us. I heard that someone said it was 2 a.m. for them. So especially big thanks, of course, for staying up late. I hope you learned something new and you saw how exciting it can be to build something with Kotlin. Make sure you check out the blog post that we have in case you haven't yet. That's not the blog post. This is the blog post because there are prizes to be won, new things to be learned, leaderboards to be dominated, whatever you would like to do. And of course, a quick reminder again that if you would like to come back tomorrow, that we will be starting 1 hour late because the JetBrains AI launch event will happen on the JetBrains YouTube channel. And Roman, who said you already tried a couple of the AI assistant things, and sounds like you only have good things to say about them.
Yeah, it's actually just amazing technology, and what is really cool, it's very much neatly integrated with our IDE, And like instead of always jumping back and forth to a browser and playing with OpenAI and trying to copying some code to OpenAI back and forth and so on, it's so much easier to like have everything inside the IDE. So yeah, just like probably tomorrow, you're gonna be really fascinated.
Wonderful. Awesome. Well, then, thank you so much again, Roman, for coming on, and thanks everybody who joined. It was a really great time. We went massively over time, but I think it was really worth it for seeing all of these things. So the next challenge is unlocking soon, I suppose, with only around about 10 hours left. So if you are waiting for that leaderboard, or if you are going for that leaderboard, maybe make sure you get a couple of hours of rest or something like that. And other than that, we'll see each other tomorrow again, an hour later. Thanks again for tuning in, and hope you have a lovely day. Take care, everybody. Bye-bye.